So one way to go about this question is to take these two equations, and since we're interested in r, we'll get rid of k. So you could either divide the two equations. That would get rid of the k. So, and the order doesn't matter. You can divide. In this case, because I like to keep larger numbers in the numerator, I'm going to divide the second equation by the first. So that becomes 5. K knocks out, and then 4 to the r over 2 to the r is same as 4 over 2 to the power of r, because we have the same exponent. So this is 2 to the r. Now some students might also rewrite this as base 2. So that would be 2 squared, 4, and then do the subtraction. So either way, you'll get the same answer. So we end up with 2 to the power of r is 5, and that means that r, which is the exponent here, base 2 of 5 is r, and that's answer choice D. So this is one way to do it. I'm sure everyone is going to do it slightly differently. You can also substitute k from the first equation to the second, which is really equivalent if you're dividing. Another way you can do this is to take logarithm of both sides, and we'll do to base 2, because that's kind of what we see here, and then 4 will also be related. And this might be important in other questions as well. So you're taking log base 2, so this would become log 2k plus, because this is a multiplication, 2 to the r, and then this will be just r, because the rule is you bring the exponent to the front, and then log of 2 to the base 2 is just 1. So this piece is r, and then we'll leave this part here. And then next we're going to do the same thing with the second equation. So log 215, we'll get log 2k plus log 2 4 to the r, and this will be r times log 2 4, and this is 2, because 2 to the power of 2 is 4. So that becomes 2r, and you'll notice the log 2 part is the same. And we can subtract the two equations. So I'm subtracting the first one from the second. And you'll notice that this term will drop out. You'll end up with r. And this is subtraction, so this would be the same as dividing 15 over 3, which is 5. Now, certainly this method, compared to the first approach, looks longer. But I just wanted to illustrate another way to go about it. And I think it is important to know how to take log of both sides if you're given an equation with exponents in it. So certainly, this method will be helpful in other questions, but certainly you can just go about it this way. And I'm sure there are other ways to also do it quickly. So to summarize, the answer is D.